Quasars or quasi-stellar radio sources are the most energetic and distant members of a class of objects called active galactic nuclei. Although the true nature of these objects was controversial until the early 1980s, there is now a scientific consensus that a quasar is a compact region in the center of a massive galaxy surrounding a central supermassive black hole. Quasars show a very high redshift, which is an effect of the metric expansion of space between the quasar and the Earth.
This radiation is emitted across the electromagnetic spectrum, almost uniformly, from X-rays to the far infrared with a peak in the ultraviolet optical bands, with some quasars also being strong sources of radio emission and of gamma rays. Because these changes occur very rapidly, they define an upper limit on the volume of a quasar. Quasars are not much larger than the Solar System. The highest redshift quasar known is Ola's J1120 plus 0641, with a redshift of 7.085, which corresponds to a co-moving distance of approximately 29 billion light-years from Earth. Quasars are believed to be powered by accretion of material into supermassive black holes in the nuclei of distant galaxies, making these luminous versions of the general class of objects known as active galaxies.
Quasars may also be ignited or reignited from normal galaxies when they merge and the black hole is infused with a fresh source of matter. Although quasars appear faint when viewed from Earth, they are visible from extreme distances, because quasars are the most luminous objects in the known universe. In a universe containing hundreds of billions of galaxies, most of which had active nuclei billions of years ago but only seen today, it is statistically certain that thousands of energy jets should be pointed toward us, some more directly than others. This means that quasars generate and emit their energy from a very small region, since each part of the quasar would have to be in contact with other parts on such a time scale as to allow the coordination of the luminosity variations.
To create a luminosity of 1040 watts, the typical brightness of a quasar, a supermassive black hole would have to consume the material equivalent of 10 stars per year. Quasars also show forbidden spectral emission lines which were previously only seen in hot gaseous nebulae of low density, which would be too diffuse to both generate the observed power and fit within a deep gravitational well. One strong argument against them was that they implied energies that were far in excess of known energy conversion processes, including nuclear fusion.
A grouping of two or more quasars can result from a chance alignment, physical proximity, actual close physical interaction, or effects of gravity bending the light of a single quasar into two or more images. When two quasars are so nearly in the same direction as seen from Earth that they appear to be a single quasar, but may be separated by the use of telescopes, they are referred to as a double quasar, such as the twin quasar. When the observed redshift of quasars is interpreted in terms of Hubble's law, it is inferred that quasars are very distant objects.
The first true triple quasar was found in 2007 by observations at the W0106, was first observed in 1989, and was found to be a double quasar. This triple quasar has a redshift of Z2.076, which is equivalent to 10.5 billion light-years. In 1963, a definite identification of the radio source 3C48 with an optical object was published by Alan Sandage and Thomas A. Astronomers had detected what appeared to be a faint blue star at the location of the radio source and obtained its spectrum. Its size is from 10 to 10,000 times the Schwarzschild radius of the enclosed black hole.